Hello and welcome students. Welcome back to my channel. Today in this video I have come with certain basic fundamentals of electromagnetic waves which will be very useful for 12th board and of course Neet and JEE mains as well. So without wasting time, let us continue with that. Okay. So students, as you can see that earlier in the earlier what you call this thing video, I have already given the basics of Maxwell's four equations, Maxwell's equations. Today we'll be mainly studying about the origin of electromagnetic waves, that is how electromagnetic waves are produced, and also what are the basic properties or fundamental properties of an electromagnetic wave. So first of all, let us understand the origin of electromagnetic wave. How a wave is produced, electromagnetic wave is produced. Now students, it's very simple. The simplest form I would say is an oscillating charge. Okay. An oscillating charge will produce electromagnetic wave. Because a simple charge will have only electric field. A moving charge, a charge moving with constant velocity, will be having electric field as well as magnetic field. But the underlying idea is the magnetic field must change. So for that, the charge must accelerate. If the charge starts accelerating, it will produce a changing electric field, and a changing electric field will give rise to a changing magnetic field, and a changing magnetic field in turn gives rise to an electric field. So this way they regenerate each other. So the simplest mode could be an oscillating charge which is oscillating to and fro. This is the simplest mode. The other way of generating electromagnetic wave is this. You can have a capacitor and you can have a inductor, discharge capacitor. Okay. As soon as the key is switched on, here you can have some key. You can see the charge on the capacitor will start oscillating. That is, the capacitor will get charged, then it will get discharged, then again it will get recharged, then again it will get discharged. So this way charge starts oscillating. So this is also a source of electromagnetic waves. Alright students, I hope that is clear. Alright. Now one fundamental aspect of electromagnetic wave is this. The frequency of the wave may be same as the frequency of the source. Very important point. Frequency of EM wave will be same as the frequency of the, if it is oscillating charge, then frequency of oscillation, frequency of the source. Okay students. Then for example, if you want to generate, let us say, microwave of frequency 10 to the power 10 Hz, we should have an oscillating charge which should oscillate with a frequency of 10 power 10 Hz. So automatically it will be able to generate an electromagnetic wave. Okay. Then now basically all this you can understand, okay, in this manner. During the charging of the capacitor, as we know, the electric field was directed in this way, okay, along the length of the parallel plate capacitor. Then the magnetic lines of force were like this, magnetic field lines in fact. Okay, and the wave will propagate in this direction. The wave propagation direction will be like this. So basically, the electric field will be perpendicular to magnetic field, which will be perpendicular to the direction of propagation. direction of propagation. Okay, students? Right. So, next we'll see the characteristics of EM wave. The characteristics of EM, that is electromagnetic wave. The simplest diagram involves, students, a wave propagating along x-axis, okay, this way, then electric field along y-axis and magnetic field along z-axis. So this way electric field is like this, magnetic field is like this, and so on. So when electric field is at its peak, at the same instant, magnetic field is also at its peak. When electric field is zero, magnetic field is also zero. When electric field is in the reverse direction at its peak, magnetic field is also in the reverse direction at its peak. Again, both are simultaneously zero. Then again, when electric field is at its peak in its positive direction, magnetic field is also at its peak in its positive direction. This is how it. In other words, both vibrate with the same phase. The electric field and magnetic field keeps vibrating with the same phase, and basically they are sinusoidal waves. So first and foremost property which we have to realize or understand is this. If you see, students, there is a constant known as propagation constant. Propagation constant. Okay. So basically its numeric value is 2 pi by lambda, and it has the direction same as the direction of propagation of wave. It is a vector with direction in the direction of wave propagation. So you have to understand this, students, that if you take electric field, magnetic field, and the propagation constant in a cyclic order, then in this way, E cross D will be parallel to K, then vector B cross vector K will be parallel to vector E, and vector K cross vector E will be parallel to vector B. It is just like I cap, J cap, K cap, that is the orthogonal triad of unit vectors. I cap cross J cap is in the direction of K cap, then J cap cross K cap is in the direction of I cap, and K cap cross I cap is in the direction of J cap. Somewhat similar to that. So this will help you to find the direction of any one given the direction of any other two. Okay, students? Right. Then, second point is this. Remember, students, the diagram which I have drawn is a plane progressive wave. It's a plane progressive wave because the electric field and magnetic field, they are oscillating in a single plane. So that's the name plane progressive wave, and it's also proceeding or advancing with a speed equal to that of light, of course. The second point we have to understand is the ratio of peak value of electric field and peak value of magnetic field, or the ratio of RMS values of electric field and RMS values of E will be equal to C, that is speed of electromagnetic wave, speed of EM wave, that is speed of light. In vacuum it will be 3 into 10 power 8 meters per second if it is in vacuum. Okay, students? Very important point. Then also, according to Maxwell's equation, it can be shown that the speed of a wave, speed of electromagnetic wave in a medium is equal to this. where mu is the absolute magnetic permeability of the medium, and epsilon is the absolute electrical permittivity of the medium. I'll write it here, students. Absolute magnetic permeability, whereas epsilon is absolute electric permittivity. Okay. So this also has been proved as per Maxwell's theory. So on this basis we can say, therefore in vacuum it will be this. You have to make use of the values of mu and epsilon for vacuum. Okay. So this will roughly be 10 to 10 power 8 meters per second, students. Also you can understand that refractive index is given, let us say m, refractive index of a medium, okay, of a medium m, is equal to speed of light in vacuum upon speed of light in medium. The speed of light in vacuum is, just now we saw, it is under root mu 0 epsilon 0. Speed of light in the medium is under root mu epsilon. So basically we have the ratio mu by mu naught into epsilon by epsilon naught, which is equal to under root mu r into epsilon r, where mu r is the relative magnetic permeability of the medium and epsilon r is the relative electrical permittivity of the medium. Okay, relative permeability, and epsilon r is the relative permittivity of the medium. Okay, students. Then, as we have already discussed, that the frequency of the electromagnetic wave will be same as the frequency of the source. By the frequency of electromagnetic wave, we mean the frequency of the electric field or the frequency of magnetic field. Frequency of EM wave is basically the frequency of electric field oscillations, or it is also equal to the frequency of magnetic field oscillations. Okay, students? Right. Then, as we know, for any wave, particularly sinusoidal wave, we can express like this. Okay, the displacement is equal to amplitude into sine of kx minus omega t, if it is going along x-axis, positive x-axis. Okay, students. So A is the amplitude, K is the propagation constant or the wave constant, also called as propagation vector here, and omega is the angular frequency. Okay, and we all know that K is 2 pi by lambda and omega is 2 pi into frequency or 2 pi upon time period of oscillation. Okay, so here in this case we can express the electric field in this way. Electric field has its amplitude into sine of kx minus omega t. Similarly, the magnetic field can be expressed as its peak value into sine of kx minus omega t. So students, here omega, from omega you can obtain the frequency, and this is the frequency of the electromagnetic wave. Okay, and after you can obtain from here, you can notice that both have the same phase. You can see this angle is the phase, students. The angle coming within the sign in these equations is the phase. So both have the same phase. That is the reason we read here that both attain the peak value simultaneously, that is electric field as well as magnetic field, and both attain their zero simultaneously. Both change their direction simultaneously. So the variation is simultaneous, because the variation is basically due to what? This phase only. As this phase, that is angle, keeps changing with time, its sign value changes, and accordingly electric field and magnetic field keeps changing. So this is how we have to follow. If we understand this much, that is enough. One last point, students, before we wind up, is this. As we know, a charge, a wave is basically characterized by its energy. Because without an energy, there is no question of any wave. A wave cannot have its existence, or a wave cannot owe its existence without the concept of energy. So basically, wave is associated with energy, and in case if it's a progressive wave, the energy will get carried away in the direction of propagation. So here also electric field, we know it is associated with energy, as well as magnetic field is also associated with energy. So basically electromagnetic waves carry energies in the form of electric field and magnetic field. Right. So the energy density due to the electric field is same as energy density due to the magnetic field. This is the other thing you have to understand, the students. Okay, it can be proved very easily. Okay, using this relation. Which relation? This one. This relation. Using this relation, it can be very easily proved. So let us prove this. Okay, students. Right. So let us start from the left hand side. The energy density corresponding to electric field. We know, assuming the wave to be traveling in vacuum, we can write half epsilon 0 E square, where E is the RMS value. Okay, because we are basically considering the average energy density of electric field, averaged in space over a large time, over a long time. So now, since we know that ERMS is equal to C into BRMS, C is the speed of light in air or vacuum. So we can write like this. And also, we know that C naught square is 1 upon mu naught into epsilon 0. From here, students, from this equation, you can see this is the equation. C naught is basically equal to 1 upon under root mu naught epsilon. So when you square it, you get this. Then epsilon 0 gets cancelled, and finally we are left with this BRMS square by 2 mu naught, which is nothing but average energy density due to the magnetic field. So the two are equal. So that is, we can say, total energy density, carried by the wave, okay, will be equal to energy density due to the electric field, average energy density due to the electric field, plus average energy density due to the magnetic field, which can be written as twice average energy density due to the electric field, or twice average energy density due to the magnetic field. So this will be epsilon 0 ERMS square, or this will be BRMS square by mu naught. Okay, students. Now we know that ERMS is peak value by root 2. So substituting this, we can write this as ERMS square can be written as E naught square by 2. Similarly, BRMS square can be written as B naught square by 2. Okay, students. That's all, students, in this video. Next, what we are going to do, we are going to solve certain numericals, okay, for NCERT. So I have already picked up those numericals, you can see, students. So quickly let us solve NCERT questions here. So question number 8.3, you can see, student, what physical quantity is same for X-rays of wavelength this much, the red light of wavelength this much, and radio waves? So the answer is speed. Okay, students, speed of light is same as speed of X-rays or speed of radio waves, etc. Because basically all are electromagnetic waves. Okay, and the speed of electromagnetic wave will depend only on the medium. Assuming that all these waves travel in medium, their speed would be around 3 into 10 power 8 meters per second. Is that clear, students? Moving to the next question. A plane electromagnetic wave travels in vacuum along z direction. What can you say about the directions of its electric and magnetic field vectors? Alright, so let us say that you have x-axis like this here, y-axis like this here, and z-axis. Okay, so it is basically the wave is propagating along z direction is given. So naturally, the electric field and magnetic field must oscillate perpendicular to z axis, that is somewhere in the xy plane. Also, the two should be at right angles to each other. So if electric field is like this, probably magnetic field can be like this. So that vector E cross D should be in the direction of K. K is in the direction of wave propagation, students. Okay. So once again I repeat, both electric field and magnetic field must lie in the xy plane, because only then they will be at right angles to the direction of propagation, that is z axis. Second thing, electric field and magnetic field should be at right angles to each other. For example, if electric field is along x axis, probably magnetic field would be along y axis, and so on. Also, vector E cross vector B should be parallel to the direction of propagation. So this is very important, students. Then the second part, the frequency of the wave is 30 megahertz. What is its wavelength? We all know that speed is connected with frequency into, for any wave. This is true for light wave also. So basically we have 3 into 10 power 8 meters per second. Frequency is given as 30 million or megahertz, that is per second. Sorry. And we require lambda. So as you can see, lambda is basically 10 power 8 minus 10%, 10 meters. Okay, this is 10 power 7, this is 10 power 8. 3 gets cancelled. Moving to the next question, students. A charged particle oscillates about its mean position with a frequency of this much. What is the frequency of the electromagnetic waves produced by the oscillator? As we know, students, what will be the frequency of the source? Here the source is the charged particle. The frequency of the source, same frequency will be the frequency of the electromagnetic wave. So frequency of the electromagnetic wave will be exactly 10 to the power 9 Hz without any doubt. Then next question. The amplitude of the magnetic field part of the harmonic electromagnetic wave in vacuum is this much. What is the amplitude of electric field part? We know, students, always remember C is equal to E naught by B naught. Okay, students. So based on that, you can write electric field amplitude is C into B naught. So C is, we know, 3 into 10 power 8 meters per second, and B naught is 510 nanotesla. Nano means 10 power 9. So we have substituted everything in SI. So 3 into 51 is how much, students? 153. Exactly this will get cancelled. So 153 Newton per coulomb is the answer. Then moving on to the next question. Suppose that the electric field amplitude of an electromagnetic wave is this much, and that its frequency is n equal to this much, determined B naught omega k and lambda. Right. So we can very easily find, so as B naught can be found from E naught from this formula. C is equal to E naught by B naught. Therefore, B naught will be E naught by C. Okay, so E naught is how much? 120. SI C is 3 into 10 to the power 8 meters per second. So finally we have 12 by 3 is 4 into 10 to the power minus 7 Tesla. Minus 8 plus 1. Then we have to find omega. Now omega is 2 pi into n. So since n is given, so we can write omega as 2 pi into frequency. So 2 pi into frequency is how much? 50.0 megahertz. So 50 million hertz. Okay. So finally we can write this as pi into 10 to the power 4. Sorry, 6 plus 2 is 8. 8 radian per second. Or you can write it in decimal, 3.14 into 10 power 8 radian per second. Then we have K. So K will be, yes, see students, one simple formula we have to understand. Now speed is equal to distance by time. You all know this. Distance covered in one time period is the wavelength. So multiply dividing by 2 pi, we can write like this. So 2 pi by t is omega, and lambda, 2 pi by lambda is k. So we can always have c equal to omega by k. So therefore we have is equal to omega by c. Okay. So omega is pi into 10 power 8 radian per second. C is 3 into 10 to the power 8 meters per second. So finally we have 5 by 3 meters per second. Maybe 1 point something. 1 point. Because pi is 3.14, so slightly more than 1. Then we have lambda. We require lambda here. So lambda will be 2 pi by k. Since we have already found k, we can substitute here 2 pi by k. K is pi by 3. So you can have 6 meters as a limit. Then find expressions for E and T. Now since we doesn't know anything about the direction of propagation and all, we can only assume certain things. So let us assume that the wave is propagating along x-axis. Okay, and let us say at any instant electric field is along y-axis. So certainly magnetic field can be along z-axis. Okay, students. So here electric field can be written as peak value is 120 Newton per coulomb. Okay, I am not writing the units. We can assume it the units to be in SI into sine of omega t. Omega is what? Omega is pi into 10 power 8. Omega is pi into 10 power 8. So pi into 10 to the power 8 t minus, because we are assuming that it is going along the positive x direction, minus kx. K is pi by 3. So pi by 3x. All the quantities are in SI units and E is along y-axis. So j cap, you have to multiply with the unit vector in that direction. Similarly, students, let us say we have to find vector b. So vector b magnitude. What is the peak value we got? We got 4 into 10 power minus 7 Tesla. So we can write 4 into 10 power minus 7 Tesla, and thus everything will be same, because electric field and magnetic field oscillate with the same phase. So you can write like this as it is. Remember, it is oscillating along z-axis, so k cap. You have to attach this k cap. Right, students, moving to the next question. In a plane electromagnetic wave, the electric field oscillates sinusoidally at a frequency of this and amplitude. What is the wavelength? Students, frequency and wavelength are always related with this formula. That is C equal to F lambda. So we know the frequency, we can find wavelength. Okay. First we have to find wavelength A part. So wavelength will be equal to C by F. So speed of light is 3 into 10 to the power 8 meters per second, and frequency is 2 into 10 to the power 10 hertz. So this will be basically 1.5 into 10 to the power minus 2 meter, which is 1.5 centimeters. Then coming to B part, what is the amplitude of the oscillating magnetic field? So if you know the what you call amplitude of electric field, you can find the amplitude of oscillating magnetic field from this equation. C is equal to E naught upon B naught. Therefore, B naught will be E naught by C. Okay. E naught is 48, C is 3 into 10 power 8 meters per second. So 48 by 3 is 16. So 16 into 10 power minus 8 Tesla. Okay. Then show that the average energy density of the electric field equals the average energy density of the magnetic field. We have already shown this. You can just refer to the previous section. Okay, in this video itself I have shown this. Then coming to the next question. Suppose that the electric field part of an electromagnetic wave in vacuum is this. What is the direction of propagation? You can see, students, y is coming and plus is coming. So it is along the negative y direction. So this is along the negative y axis, we all know. Then what wavelength? Wavelength you can obtain from this. This quotient of y is k, basically k is 2 pi by lambda. So 2 pi by lambda is basically 1.8. So from here you can find lambda in meters, of course, students. Okay. Then similarly frequency. Frequency can be obtained from the coefficient of T. Coefficient of T is omega and omega is always equal to 2 pi. So 2 pi into frequency is equal to this, that is 5.4 into 10 to the power 6 per second. So from here you can find frequency, students. Similarly, what is the amplitude of the magnetic field part? Since we know the amplitude of the electric field part, we can use the formula C is equal to E naught by B naught. Therefore, B naught can be obtained from E naught by C. E naught is this, C is 3 into 10 power 8 meters per second. So accordingly we can find that. Write an expression for the magnetic field part. In fact, whatever value you get, students, for the magnetic field, okay, so magnetic field part you can write like this. Remember, this electric field vectorially given. So magnetic field part will be whatever value you get here, you write here, and then you copy this entire thing, okay, cos 1.8 radian per meter into y plus 5.4 into 10 to the power 6 radian per second t, and then you can see, since it is propagating along negative y-axis electric field, and electric field is along, electric field is propagating along negative y-axis, and electric field is along positive x-axis, then we know that E, B and K. So K cross E should be in the direction of B. Okay, students? B will be parallel to the direction of vector K cross vector E. Vector K is the direction of propagation. So direction of propagation is along negative y-axis. So this is along negative y-axis. Electric field is along positive x-axis. So minus j cap cross I cap is basically k cap. Okay, students. Once again, because minus j cross I will be k cap. So basically, you have to attach this unit vector in that direction. Okay, students. So that's all in this video, students. Thank you for watching my channel. Kindly subscribe to this and hit the like button. Thank you so much.